Okay, so these are the outside of class examples for 1.1. Determine the number 17, determine whether the curve is the graph of a function of x. If it is, state the domain and the range of the function. So we're looking at this curve to see whether or not it is a function. Whenever you have a graph of something, you can use the vertical line test to determine whether it's a function. And that means that if you draw a vertical line and you hit the graph twice, then it is not the graph of a function. And so every vertical line that I draw, and I should be able to draw, infinitely many vertical lines, should only hit the graph one time if it is a function. So I'm going to try to draw a vertical line right here, and I notice, well, I only hit the function one time. I only hit the curve one time, I should say. Oh, it's a function. And so I only hit it one time, so far so good. If I draw here, only hitting once for each of these. If I draw here, only hitting once. So you can kind of see that, hey, anywhere I draw over here, I'm only going to hit once. Now you might be wondering, well, what about in this zone here? And so if I draw here, it hit once, but since this was open right there, it's not hitting at that point. If I draw just a little bit to the right or left, it only hits once. These vertical lines only hit once. And so, yeah, I'm thinking, hey, this is a function. And so I'm going to answer this question. I'm going to say, yes, it's a function. And I'm going to say by the vertical line test. That's what I used to determine that it was a function. I'm going to draw these, wipe these lines off here that I drew my vertical lines on here. So now it's wanting me to say the domain. And so now what I'm looking at is this curve I have, which I know is a function. What values of x is it defined for? That's what the domain is. And so the x's are left and right. So if you kind of thought of every point that is on this curve as being an ordered pair, well, those ordered pairs would have an x, each ordered pair, and a y. But I'm only interested, when I'm talking about the domain, in the x. So here I know that this hasn't been labeled, so I'm going to label 2 and 3 here, and -1 and -2 and -3 here. And so I like to kind of go, I like to start over on the left and kind of go left to right. So as I look over here on the left, the farthest that it goes is -3, and I can see that it's defined here at -3. So and so my domain is going to start at -3 and include -3. And then I just kind of move over. Is it defined at -2.9? Yes. Is it defined at -2.5? Yes. Is there anything in between that's kind of going to be left out? No. At -2, you're thinking something might happen, but it's defined. It actually has an output of -1. And so it's defined there at -2. Was it defined at -2.1? Yes, whatever this value is down here, right? This is -1, this is -2, a little bit smaller than -2, right? And so then, what about, is it defined for 1.9? Well, yeah, almost -1. And so as I go along, is it defined at -1? Yes. Is it defined at -0.75? Yes. It's over here. Is it defined at -0.5? Yes. So all the way, is it defined at, well, that's where it ends, is at 2. So every value, was it defined for x is half? Yes, it's right there, that point, whatever that point is right there. So it went from -3 to 2 and left no values of x out. So it starts at -3. Remember, we use a bracket to show that it includes -3. And so our domain started at -3, and then comma, it ended, was it +2? Yeah, it was +2 and included +2. Then we're going to say the range. Now the range is the y values, and that's how far down and how far up. That's what I say to myself. So I always like to start at down. And so here I'm going to put -3. Our values for y begin here at -3, and they include here, this point right here is y equals -3, and we do have a point right there on our function. What about at -2.5? Y is -2.5. Yes, we have a value. What about at y is -2? Do we have a value? And you can see, no, we don't. So I'm looking at, okay, it leaves out y is -2. There isn't, there's built of many ordered pairs, and there isn't an ordered pair that goes with y is -2. So far, our range goes from -3, including -3. So I'm using the brackets to show include, comma, to -2, but does not include -2. -2 is left out. And then I can continue on. Well, what about -1.9? No, it's not defined for -1.9. What about for -1.5? No, y is -1.5, it's not defined. What about y is -1? Oh yes, that's where it begins again. So we're gonna union, and it included -1. So it starts at -1, and then what about at -0.5? Yes. What about at 0? Yes. Anything left out in between? No. What about at half? Yes. What about at y is 1? Yes. What about at y is 2? Yes. And when I get up here somewhere at y is, maybe you might be saying 2.6 or so, it actually has 2 points. And is that okay? And the answer is yes, it is. It's okay. It was a function, but it's not a one-to-one function, meaning that each y value would have only one x value, but it's just a function. And so, but is it at 2.5? Yes. 2.6, yes, and yes, right? All the way up to, it looks like 3 to me. That's the very highest that it goes. Right here is 3. And so when y is 3, we have a point there. And so this includes here to 3. And it included 3, so I'll put a bracket on it. So there we've answered that question. If I kind of flash the solution guide here for number 17, I'm going to erase. And, but here they say, yes, the curve is the graph of a function because it passes the vertical line test. The domain is brackets -3 to +2, brackets just like we had, and the range is from -3 to -2, not including -2, and then again from -1 to 3. And so, yeah, so we did a pretty good job on that one. We'll try the next one, see how we go. And this is problem 42. Okay, it asks us to find the domain, so it's already telling us it's a function, and it's asking us to find the domain. This eraser really does not work that great. So since I have roots, what we know is you can't have the square root of a negative. So underneath that radical 3 minus t, that square root, needs to always be positive. So all the values of t that we're choosing, domain, remember, is the input values, which in this case the inputs are t, have to be able to go in your function and be defined. And so the square root of a negative is not defined. And so what we know is that this radicand right here, I'm going to make a box around it, 3 minus t needs to be greater than or equal to 0. And then we have this one as well. And so what we know is also this has to be true. So and also 2 plus t has to be greater than or equal to 0. So as long as both of those things are true, then we'll be picking values that are in the domain. That won't make our calculator say undefined. And in fact, I was going to bring a calculator. Maybe, Kevin, could you look at my red backpack there and see if I do have a calculator? I bet I do. Okay, so I want to solve this for t. And I like to have my t on the left side, which I already have it on the left side. So I would probably take away 3, both sides. So I get negative t is greater than or equal to -3. Thank you. And then I'm going to divide by -1. And I don't know if you guys remember that when you divide an inequality by a negative value, that you have to flip the inequality symbol. So here I get negative t divided by -1 is t. I need to flip because I'm dividing by a negative. It's physically that I'm dividing by -1. It's the negative. Could have been -6, or and if you multiply. If you add or subtract, then you don't flip the symbol. So I need to flip that symbol, and I'm going to get negative divided by a negative is a positive. So that's saying that t is less than or equal to 3. And then we have this other condition, 2 plus t is greater than 0, so we're just going to subtract 2 from both sides. And no reason to flip. And remember, this is and. So in order to answer this question, because I haven't got it down, I've solved them separately, right? And I'm saying this and this. What I'm going to have to do is I'm going to have to put them on a number line, and then it needs to meet both conditions. And I'm going to draw this one in blue. Hopefully that blue shows up. Kev will kind of look and see, does that look like that blue showing up? Okay, so I'm going to draw my number line. I'm going to put 3 here on my number line. I was kind of noticing -2 will be over here. And then it includes 3. And it is the things that are bigger than 3. It is the things that are smaller than 3. I'm sorry, I looked at that and I was like, oh my gosh, it's the things that are smaller than 3. I'm sorry, I was looking at it and said to myself bigger. I don't know why I did that. Okay, hopefully we'll be able to tell the difference between purple. And so this is, I'm going to put -2 just over here. I don't have really good scale going. I'm not even trying to have scale. So I could have counted it all out there, but that's not important here. What's important is that -2 is on the number line to the left of 3. That's, if I'd drawn that backwards, that would have been bad. Okay, so now we're saying includes -2 and all of the things that are bigger. And then what we want to do to say where our solutions are for the domain is we want the things that meet both conditions. That's what and means, that it has to meet both conditions. So the things that are over here smaller than -2, they only meet this one's condition. I was going to circle that in purple and I didn't. So they only meet blue. They only meet blue's condition, right? They only meet this one's condition, this stuff over here. This stuff in between, because it's got both blue and purple, meets both conditions, and that's what we're looking for. And then over here only meets purple's condition, and so it doesn't meet blue's condition, and so it's not part of our solution. Our solution was and, needed to meet both. And so the things that meet both are in between, and so our solutions start here at -2 and end here at 3, and include 3. And so then you can kind of check it if you like, just to kind of make sure that, hey, you know, is that really gonna work? And so what we're saying is it's okay to pick for t any value between -2, including -2, and 3, and including -3. So for example, 0. It would be okay for me to pick 0. So if I did that, so this is just for example, this is extra that I'm giving you just to make sure that we understand what we're saying. For example, if I asked you to find g of 0, it should work out. So we would have 3 minus 0 minus 2 plus 0. So 3 minus 0 is 3. This would be the square root of 3, which is a number around 1.717. I don't know, you can use your calculator. Minus the square root of 2, right, which is 1.414 or so. And so yes, that is some number, right? Everything's totally fine. And so we knew this was going to be good because we had picked a value that was within the domain. If we pick a value outside of the domain, then we know that it's not going to be good. So for example, if we picked 5, see how 5 is outside of what we said the domain was? And so we know that this is going to be not good, right? It's going to be undefined. So if I pick g at 5, then this would be the square root of 3 minus 5 minus 2 plus 5. So just replacing in for t, 5, right? And then here I have the square root of -2. And that's what's the problem, right? Can't have the square root of a negative. Minus the square root of 7. Well, this was actually okay, but this part is undefined. So that's why this one wasn't good. And so this would be undefined. And they were asking us to find where it is defined, right? And so we just by picking something outside of what we said our domain was. Now you can go and test -1 and you'll see the same, that hey, -1's undefined as well. Okay, so we did a lovely job on 42. We're going to try 58. So I have to erase this. It erases so poorly I feel like I need to spit on it, which would be pretty gross. Okay, so they want me to sketch this graph, and so you can do it any way you like. And picking a bunch of points is something, I like to pick a few points, but picking a bunch of points here is not gonna work that well. What I would start off with is just kind of thinking about the graphs. If I asked you to graph y equals the absolute value of x, well, you know, I'm hoping that it looks like this. And I hope that's one that you can just whip the graph out. It's one of the, I don't know how many there are, but they say the basic graphs, 6 basic graphs. I know that one of my colleagues always says there's 6 basic graphs, and then when I ask her to name them out, she always names 10. So we'll say it's one of the 10 basic graphs. Okay, and if I take away 1, so I'm going to look at this, y equals the absolute value of x minus 1, then what that should do is it should take this graph right here and it should just lower it down 1. Every single point be lowered down 1. So here, I'm going to be starting here at -1 and then here. Okay. Then, if you put absolute value around this, right, so I'm just kind of building out, well, that should make, absolute value makes things that are positive, positive, and it makes things that are negative, positive. And so it should take this part, which is positive, and leave it alone. It should take this part, which is negative, and it should make it positive. And this is negative, so this whole piece is underneath the x-axis, so it's negative, so it'll make it positive. And then that's positive, above the x-axis is positive, so it'll leave it alone. So we'll have here y equals, and then we're going to have the absolute value of x minus, absolute value of x minus 1. And so what this is going to do is it's going to take this part right here and leave it the same. And then it's going to take that part right there, and it's just going to flip it up, right? And I guess I don't have that quite connecting. And then I have the graph over there, the grid over there. So I kind of was just putting here, but I want to make sure that we have the right points kind of going along. And so when this lowered it 1, where is it crossing right there? Because I want to make sure that I get that right on there. And so, well, that's where the y on the x-axis, that's where y is 0. So if we think about y being 0, well, that would have to be 1, right? So definitely it's over here at 1. This point right here is at 1. And what about right here? I want to know that point. Well, that's that point right there. And it's where, right here, where y is equal to 0, again, on the x-axis, well, also at -1. And so right here at -1, so here was 1, and so when I go to draw that, right, as I'm kind of looking along, you know, I want to know, I mean, I know it's a straight line, you know, over here at 2, where is that at 2? Well, you can always put it in and find out, right? The absolute value of 2 is 2, minus 1 is 1, the absolute value of 1 is 1, so it is here at 1. And so I feel now that I've kind of done a combination of using my idea and also picking maybe a couple of points here just to make sure. And so now I want to make sure this goes down to -1, so when I flip it up here, it should be at +1. And here, and here, and if you needed to, you could pick a few points over here as well, just to make sure. So we kind of drew, it looks like a W, right? Okay, so we did a lovely job on that one. Okay, a few more is symmetry in the extra examples in 1.1, the outside of class examples in 1.1, just to make sure. I was totally review from your pre-calc stuff. Symmetry, a graph is symmetric with respect to the y-axis if every point AB is on the graph, then the point negative AB is also on the graph. This is what it's going to look like if it's symmetric with respect to the y-axis. It's going to be, you know, kind of like a mirror image. The test that you can use to see that if it's symmetric with respect to the y-axis is replace x with negative x in the equation, and if the equation can be simplified to be exactly what you started with, then it does have y-axis symmetry. And so also called an even function, and when it's an even function, then the test, because you have it in function notation, is that if f of negative x equals f at x, then it's an even function. Then the next one is something that has x-axis symmetry. That's if AB is a point on the graph, then A negative B is a point on the graph. So here's AB and A negative B. And you can see here is a parabola on its side. This will not be a function though, right? Vertical line test, it's not a function. If it has x-axis symmetry, it's not a function. And so the test that you can do if you have an equation and you're asked to, you know, hey, is to replace y with negative y and see if you can simplify it to exactly the same equation. And we don't call it anything like, because it's not a function, so we don't say even function or odd function or whatever. Okay, so the graph is symmetric with respect to the origin. If AB is on the graph, then negative A, negative B is on the graph. So here's AB on the graph and negative AB on the graph. And how you can test whether or not it has symmetry with respect to the origin is replace x with negative x and y with negative y. And if you can simplify it to the same equation, then it is have origin symmetry. Things that are functions and have origin symmetry. So there's some things that are not functions that have origin symmetry, but if it's a function and it has origin symmetry, then you'll be able to see that. Called an odd function if f at negative x is equal to negative f of x. And then it's an odd function. Okay, so we're gonna do a couple examples here. This is number 82 out of your textbook. And so they're asking me, is it odd, even, or neither? And so since they have it in function notation, and I have this is, if it is even, then this will be true. And if it's odd, then that will be true. So I'm gonna see which one of these is true. So I'm gonna start off by looking at f at negative x. And that means that everywhere I had x, I'm gonna replace with negative x. Parentheses are implied friends. So I'm gonna put parentheses instead of x in my function right here to the fourth plus 1. And now I'm gonna go fill those parentheses in, right? I'll even use red right here with negative x. And then I'm gonna see, when I simplify this, do I get back what I started with, f at x, or do I get opposite of what I started with? So negative x raised to the second is, when you square that negative, you get a positive, and so actually this is equal to x to the second. And the same with when you raise it to the fourth, it's equal to the fourth. So actually I got it back exactly what I started with, right? So this is equal to f at x, and so this tells us thus it's even, right? Because this, true, right? Okay, so we did a lovely job on that one. It's an even function. This is problem 83 out of your book. Same idea. So where I see x, I'm just putting parentheses. And I'm going to fill those parentheses in with negative x. And they're not being raised to the second or anything like that. And so, you know, that's just negative x up there in the top. I'm going to write negative 1 times x. Maybe I won't write the 1, but I'm wanting to separate that negative off there from that x. And then down here, negative x plus 1. I guess I'm just drop my parentheses because it wasn't being raised to the second, wasn't being raised to the third. I guess what I'm asking you, can I factor out a negative in the denominator? Because if I can, then the negatives would cancel. Or can I put this negative out to the side? Well, I can put this negative out to the side, but then it doesn't give me opposite of what I started with, right? Opposite of what I started with would look like this, negative of x, x plus 1, right? I'm seeing, can I get that, or can I get exactly what I started with? Well, if I move this negative out to the side, which I certainly can do, then I get this. But, so negative of, but that's not exactly, right, what I started with, so that doesn't quite work. And then what if I try to pull both of the negatives? So if I put both of the negatives out in the front, so this negative coming out in the front, right, that's me, and that's what I'm kind of saying, I want to put it like a negative 1. And so here, like this, and then factor out a negative 1 here, but because this is a binomial, you have to pick it out of both of them, and that's in order to be fair. And so certainly those negative 1s would reduce with one another. A negative divided by a negative, whether you put the 1 or didn't put the 1, would reduce with one another and give me x over x minus 1. But you see that that's not what I started with either. And so I cannot manipulate it using fair algebra things to be this, and I can't manipulate it to be that, no matter what I do. I guess I could have multiplied top and bottom by a negative 1. That would have been another way I could have handled it. But since I can't do that, this is neither. Okay, then this one here is, we're going to give it a try. And so f of the blank equals the blank multiplied by the absolute value of the blank, and I'm going to be filling that in with negative x. So on the outside, that's just negative x, but the absolute value of negative x is equal to, the absolute value of negative x is the same as the absolute value of x. Just think about some numbers there just for a second if you had them instead of x, that those would be they would be the same, right? Like if x had been 7, the absolute value of negative 7 would be 7, and the absolute value of 7 would be 7, right? So that those are equal to one another. If I said negative 7, or even another number, or negative 2 maybe, then that would be absolute value of 2, right? If x was negative 2, and the absolute value of negative 2 would be equal to one another. And so this is certainly a true statement. And so we have that this is negative x times the absolute value of x, right? I just replaced that with that. And now I have the opposite of what I started with. And so this is the opposite of f at x, because that's what we call what I started with. So that makes this an odd function. And so, and I've kind of showed some work to support that. And that's it. Hot diggity dog. That's it for the extras for 1.1.